Hong Kong Mathematical Olympiad 2021. We want to solve the solution with the problems with logical solutions. If you had question about anything in mathematics, Hong Kong Olympiad or other countries international level, feel free to send message to my WhatsApp number here 0098912212546 to subscribe my YouTube channel, turn on the bell to have next videos. Okay, so let's start. International Mathematical Olympiad Preliminary Selection Contest, Hong Kong 2021. Problem number 1. 100 students numbered 1 to 100 are divided into 20 groups, each with 5 students. The student with the largest number in each group becomes the group leader. What is the maximum number of group leaders whose number is prime? Okay, so we start from sometimes when you want to solve problems, instead of starting from 1, we start from the largest number, 100, especially here that we should consider largest number in each group. So the student with number 100 will be group leader and it is not prime. So the answer is not 20. The answer is at most, because the group that contains 100, the number of group leader is 100 and it is not prime. So the answer is at most 19, because we have 20 groups. One of them is bad. Now in this group we know it's bad, so let's consider we need prime numbers, large prime numbers. So here we say, okay, 99, 98, 97 is prime. We don't use it here. 96, 1, 2, 3, 4, 5, 95. We are just analyzing, and then I tell you, for example, if this problem was, for example, in round 2, how to prove. So now we are working on finding a good example. The next one, 97, you say, okay. You use 94, who's not prime. 93 is not prime. 92 is not prime. 91 is not prime, because 93 is multiple of 3, multiple of 2, multiple of 2. 91 is 7 times 13. 1, 2, 3, 4, 5. So this group was bad. This group is good. Now let's see 98. Now again 90. 90 is not prime. So again, if you use 90, we have 88. You don't use 89. 87 multiple of 3. 86 multiple of 2. 85 multiple of 5. So this group is again bad. So we easily understand that the answer is at most, we've proved, at most 18. Because if you consider the numbers 100 to 90, 90 to 100. In this, there are how many numbers? 11 numbers. We have only one prime number in this group. So, but here there are 11 numbers and they are larger than other numbers. So these numbers are in at least 3 groups, because there are 11 numbers. Only one of them is prime, so at most one of them is good. So at least we have 2 groups that are bad. So the answer, we proved that it is at least 18. Now we want to prove that the answer, we can find an example for 18. Now we are trying to find an example in this problem that you want to find minimum, maximum. Also, it's important in round 2 in IMO. You should do 2 things. One of them proof, one of them finding an example. Now we are trying to find an example. So 85, it is bad. Now the next number, we want to use 89, 88, 87, 86, 85, 84. 83 is prime, so we use it for the other group. 82, 81 is 9 times 1. 80, 1, 2, 3, 4, 5. The next one, 83. Then 79, 79 is prime. 78, 77, 76 multiple of 7 and 11. 75, 1, 2, 3, 4, 5. All these groups are good. 79, 74, 70, 73 is prime, so we use it in new group. 73. And now 72, 71, again, it's good for other groups. 70, 69, 68. 1, 2, 3, 4, 5, 6. Ah, okay, so until 69 is enough. 1, 2, 3, 4, 5. Now, this group is also good. If we prove only these two groups are bad, so we found an example with 18, now the answer will be 18. So 73. Until what number we've selected? Until 69. So 68, 67, is it prime? It's not multiple of 3. Okay, so 67, we use it. You can easily, by this way, prove that all other groups will be good. 67, 66, 65, 64, 1, 2, 3, 4, 5. 63 here, 62, 61, again we use here, 60, 59 is prime number, we use it here, 58, 57, multiple of 3, 56, even 55, 54, 1, 2, 3, 4, 5, 53 is prime, 52, 51 is multiple of 3, 50 is even number, 49 is multiple of 7. And the next one, 48, 47 is prime, so we use it here, 46, 45, 44, 1, 2, 3, 4, 5. 43 is prime, 42, 41 is also prime, 40, 39 is multiple of 3, 38 is even. So again, this group we finished. 37 is prime, 36, 35, 34, 33. Here, let's consider the rest of that. 43. Until 33 we've selected. 32, 31 here is prime, 30, 29 here, 28, 27, 2, 4, 5, 26, 25, 24, 23 here, 22, 1, 2, 3, 4, 5, 21, 20, 19, 18, 17 here, 16, 5, 15, 14, 13 here, 12, 11 here, 10, again 5, 9, 8, 7, 6, and 5. Let's write 5 also here, 4. So the rest of that you say, okay, let's consider also 3 is prime, 2 is prime, 1 here. So you say, okay, 23, 1, 19, 17, 13 in this group, 1, 2, 3, 4, 5, and the other ones in this group, they're all primes except 1 here. The group leader is 23 here, group leader is 11. So we found an example with 20 groups that only 2 of them is bad. So 18 of them is good. So we found an example with 18 groups with group leader that are prime numbers. So the answer equals 18. Hong Kong Mathematical Olympiad 2021. Problem number 2. Let n be a 3-digit number which is divisible by the product of its digits. Find the greatest possible value of n. Okay, the problem says find the greatest possible value of n. This helps us to ignore many cases that are useless. Now, 3-digit number, we call it an ABC. It's a 3-digit number, is divisible by the product of its digits. So ABC divides this number, which equals C plus 10B plus 100A. Now, 3 we can conclude it is not equivalent, but 3 necessary conditions, so we need to check the last answer. If you had any question about the answer of this problem or other answers, as I said, feel free to send message to my WhatsApp number in the description and also here. And so A divides this number because it is multiple of A. So you can say A divides C plus 10B. B divides similarly C plus 100A. C divides 10B plus 100A. Now we start from A. We want to find the largest, greatest possible value of n. So A is the most important digit. At first, we want to check if A equals 9. Then what we have? If A equals 9, then 9 divides C plus 10B. And because 9 divides 9B, so we can conclude 9 divides C plus B. The next condition will change to what? B divides C plus 900. And C divides 10B again plus 900. Okay, so let's check. When we have this B plus C divides divisible by 9, we have two cases. If B plus C is 18, it cannot be 27 because B and C are at most 9. So in this case, we have 9, 9. So if we check, the number will be 999 and the product will be 9 cubed. So divisibility of this is equivalent that 9 squared divisible, we divide both sides by 9. So, and we know it is a contradiction because 1, 1, 1 is not or this sign also. Contradiction, and because 100 in some countries they write like this, in some countries write like this, in some countries they write contradiction like this. So I write this sign, but you know that this sign is contradiction. We know 1, 1, 1 sum of the digits is 3, not divisible by none, so that's a contradiction. B plus C cannot be 18. Now let's consider the case that B plus C is 9. B plus C cannot be 0 on. The digits cannot be 0 because the number is divisible by product of digit, then product will be 0, and that's a contradiction. B plus C is 9. So if we consider that B plus C is 9 and we consider the cases, okay, here if we replace, then we can say C equals 9 minus B. We know B divides C plus 900. If we replace, then it will be 9 minus B plus 900. Because B divides B, we can say B divides 909, which equals 9 times 100. B is digit, so the cases that we should check is B can be 1, or B can be 3, or B can be 9. In this case, C is 8. In this case, C is 6. In this case, C is 0. So here it's contradiction again. Now let's check these numbers. It will be 9, 18. The product will be 72. In this case, we will have, so we should check at first this case because we should consider the greatest possible number. So 3 times 6 times 9, because A is 9. So 3 times 6 times 9 divides 938. 936, sorry. Now we should check. We know it is multiple of 9, multiple of 3 also. Okay, so let's divide both sides by 9. It will be 1, 0, 4. It is not multiple of 3, but left side multiple of 3. Again, another contradiction. Now this part, if we divide both sides by, let's see, by 9, if we divide both sides by 9, because it is 9, it is 8, so let's consider the even parts. So we know it is not multiple of 4, 18, because you should consider the last two digits. 18 is not multiple of 4, 72 is multiple of 4, so again another contradiction because of 4. So we've rejected all the cases that A equals 9. So in the second case, let's consider when A equals 8, and let's copy these 3 necessary conditions to ignore many cases. Now, let's consider the case here. Okay, we can conclude 8 divides C plus 10B, because 8 divides 8B, so we can say 8 divides C plus 2B. So C plus 2B, let's see, can be what numbers? It cannot be 0 because we said C and B cannot be 0. So the first case, we start from maximum case. It cannot be, it is at most 9, 9, 18, 27. So it can be 24. Let's check at first this case. Then we check c plus 2b equals 16. And in the last case, we check c plus 2b equals what? Equals 8. We should check all of them because maybe, for example, some here is less than this, but b is greater. So we know a is 8. We want to maximize b. Now, in this case, if we consider all the cases, it will be 9, 6. Let's check. Here we have what? Here we have 8. And here we have what? 8. If you place 7, it will be 10. So only 2 cases we have here. And let's consider also this part. We know C is 20. For this part, C is 16 minus 2b. So you can say b divides 16 minus 2b for, let me write it for this part. b divides c is 16 minus 2b plus 108. 108 is what? Is 800. So we can conclude b divides 16 plus 800. It will be what? 816. So if you prime factorize, it will be multiple of 8, 102. It will be 16 times 51. 51 is 3 times 17. Okay, so we've concluded. We said, okay, B is this. Also, we can use C here. Before checking this, let's check at first these two numbers. The first number is 8. A is 8, 9, 6. And if we multiply, it will be 8 times 6 times 9. So here we know it is not multiple of 3. But here we have it is multiple of 3. The next one is 888. And it will be 8 cubed. It is 8 times 111. So if we divide both sides by 8, 8 squared must divide 111. That's a contradiction again. Also this contradiction. Now we check this part. C plus 2b is 16. Also you can consider it for this case. C divides 10b. You should multiply it by 5. It will be 80 minus 5c plus 108, which is 800. Now we can conclude C divides 880. And it is what? It is 8 times 16, we can say, because 0 has 2. So it will be 16 times 5 times 11. So let's see that C can be what numbers? C can be 1, 2, 3, no, 4, it can be 5, it can be 6, no, 7, no, 8, 8, 9 is impossible. So let's consider C plus 2b is 16. If C is 1, then C also must be even. So we don't consider 1, we don't consider 5. So C is 2. Then 14b is 7. We know B divides this, so it's contradiction. C is 4, so 12b is 6. Yes, it's possible. We should check that. C is 8. 8b is 4. Also, it is possible. So we should check these numbers. So the first number here, we should check only these two numbers. 8, 6, 4. Is it multiple of 8 times 6 times 4? And the next number, 8, 4, 8. Is it multiple of 8 times 4 times 8? Now we say, okay, we divide both sides by 8. So 6 times, let's check 3 at first. Yes, it's multiple of 3. 6 times 4, if we divide by 8, it will be 108. If we divide by 4, then 6 divides 2, 28, 7, and that's a contradiction. The next one, if we divide by 8, 4 times 8, it will be 106. If we divide by 2, it will be 16 divides 53, and that's contradiction because even cannot divide odd number. So we've reached contradiction. And the last case, when c plus 2b is 8. So we can say what in this case? We can say, okay, c plus 2b is 8 and b divides what? 8 minus 2b plus 800. And you know b divides 2b, so b divides 808, and that's 8 times 101. And the next case, if you consider c divides 10b, so you multiply by 5, it will be 40 minus 5c plus 800. So c divides 840, and you can divide by 8. It will be 8 times 105, and it will be 8 times 3 times 35. So it will be 8 times 3 times 5 times 7. So c can have many cases. Let's check. c plus 2b is 8. So b can be, c must be even. Okay. So let's check. B can be 1 or 2 or 4 or 8. If you consider it will be greater than this. So if B is 1, it is 2, 8, 6. C is 6. It is possible. If it is 4, then C is what? C is also 4. It's possible. If it is 4, then it will be 0, and that's contradiction because the product will be 0. So again, we need to consider these two cases. The first one, at first, let's consider greatest number, 824. 8 times 2 times 4. So if we check, if we divide both sides by 8, then if we divide this by both sides by 8, so you divide both sides by 8, 2 times 4 will be 8, and if you divide this by 8, it will be 103, and that's a contradiction. In the last case here, it's 8, 16, 8 times 6. So if we check this, if we divide both sides by 8, 6 divides 102. And we know 102 is 6 times what? 1 and 42, 7, 6 times 7. So it is correct. So the largest possible number equals 816. If you have any question, as I said, and with the solution or other solutions, feel free to send message to my WhatsApp number in the description. Hong Kong Mathematical Olympiad 2021 problem number 3, preliminary level. Let a and b be non-zero real numbers such that a over b plus b over a equals 5 and a squared over b plus b squared over a equals 12. Find the value of 1 over a plus 1 over b. So let's write the first one. A over b plus b over a equals a. If you use common denominator, it will be a squared plus b squared equals 5. And the next one is a cubed plus b cubed over ab equals 12. What we want is a plus b over ab. So if we consider it is sum, it is product, we want to find s over p, we can write all of them in terms of s and p. A squared plus b squared is what? Is a plus b squared minus 2ab, which equals s squared minus 2p. And a cubed plus b cubed, you can say easily it equals, for example, it has two ways. One way is this, a plus b cubed minus 3ab, a plus b. One way is this, or one way to factorize, it's a plus b times a squared minus ab plus b squared. You can use this, and we know these things, to find the answer. So it will be s cubed minus 3ps. Okay, so if I want to also find this in this way, s squared plus b squared is s squared minus 2b minus 2b minus p will be minus 3p. It will be s cubed minus 3p as the answers. The result will be same. Now, if we want to calculate the rest of that, okay, so here, let's replace the first one is 5, the second one is 12, so a squared plus b squared is s squared. Let me write here s squared minus 2p over p equals 5, so we can say, okay, s squared over p Minus 2 equals 5. So if you take negative to the other side, 7. S squared equals 7p. The next one. A cubed plus B cubed over AB. A cubed, it will be S cubed minus 3PS over what? Over AB. Over AB is what? AB is P, it equals 12. Now we conclude that S cubed minus 3PS equals 12P. We want what? We want S over P. So here you can replace S squared with 7P. It will be 7PS minus 3PS equals 12P. Then let's see, we can conclude what? We can say, okay, if we divide both sides by P is not 0 because it is in the denominator. If P is 0, A or B is 0, and we have contradiction. So if we divide both sides by, at first let's write 4PS equals 12P. If we divide both sides by P, then we have A, and by 4, S equals 3. Okay, and S equals 3, P equals what? S squared is 9 equals 7P. So we can say what? We can say P is 9 over 7. So the problem says, what is S over P? S over P will be 3 over 9 over 7. So you can divide 3. So the answer equals 7. Hong Kong Mathematical Olympiad 2021, problem number 4. 3 students, each randomly, chooses a prime number less than 100, and then the teacher multiplies the 3 chosen primes together. What is the probability that the product obtained by the teacher is divisible by 2021? Okay, because we want to check is it divisible by 2021, we should prime factorize, and the prime factorization of this number is famous. It's 43 times 47. Now, they select prime number less than 100, so we should consider them. It will be 2, 3, 5, 7, 11, 13, 17, 19, 23, 27, no, 29, 31, 37, 35, 39 is bad, 41, 43, 45, 47, 49, 51, 51 is multiple of 3, 53, 55, 57, multiple of 3, 59, 61, 63, 65, 67, 69, 71, 73, 75, 77, 79, 81, 83, 85, 87, 89, 91 is multiple of 7, 93, 95, 97. Okay, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So we want to calculate the number of good cases over all cases. All cases equals each student select 25, it will be 25 cubed. Now, we want to count the number of cases that the answers are multiple of 2021. So you can say one of them select 47, one of them select 43, and the other one select something that is not equal to 43 and 47. So in this case, we can say A has how many cases? 25, 23 cases, and then, okay, 47, 43, and another number. You multiply it by 3 factorial, because there are 3 different students. 23 times 6, it will be 18, 1, 138. If we select 41, 43, 43, or if we select 43, for example, 47, 47, only we select 43 and 47, 2 from one from the other one. The permutation here will be 3 factorial over 2 factorial 3, and similarly it is 3. So if we add up the good cases, it will be 138 plus 3 plus 3 plus 6, which will be 144. So the answer will be 144 over 25 cubed. And we can't simplify it, but let's calculate 25 cubed, it will be 5 to the power of 6. We know 5 to the power of 4 is 625. We multiply it by 25. 1, 31. 2, 5, 10. 5, 12. So it will be 5, 2, 6 here, and 5, 1. So the answer equals 144 over 15,625. Hong Kong Mathematical Olympiad 2021, problem number 5. On, Ben, and Kat join a game as a team. Each of them has to independently answer 21 yes, no questions. The questions are the same for everyone, in each of which either yes or no must be chosen. After that, the answers of On and Ben are compared, and the number of questions in which they choose the same answer is recorded. The same is done for On's and Kat's answers, as well as for Ben's and Kat's answers. The score of the team in the game is the largest number recorded. Find the minimum possible score of the team in the game. Okay, we consider the number that, for example, On, Ben, and Cats. For example, the answers that they are same. We have one case that all of the answers, for example, for one problem is same. Or 2 A, B are same, C is different, A, C are same, B is different, and B, C are same, this is different. So consider it is N1, it is N2, it is N3, N4. And it says the score. A score is what? Maximum or largest number recorded. So largest number that is recorded for A and B, the number that is recorded is N1 plus N2. In these two, N1 is the number of questions that all answers are same, and one number of questions that only A and B are same, and similarly the rest. So it will be for A and B, it will be N1 plus N2. For A and C, it will be N1 plus N3. And for B and C, it will be N1 plus N4. We can take N1 outside of this number, maximum N2, N3, N4. So at first I want to tell an example, then prove the number score is less than that. If we want to minimize, the problem says find the minimum possible. If we want to minimize score, here I select, write it with green, 0 for here, and the number of problems equals 2021. So 2021 here, if they are near each other, it's better to minimize. For example, if one of them 2021, the other one 0, it will be maximized. So if we divide 2021 by 3, it will be 6, 20, 22, 7, 11, 3, and the remainder is 2. So one of them 6, 7, 3, two of them 6, 7, 4, 6, 7, 4. And so the answer is what? Maximum of them equals 6, 7, 4. But we want to prove that, for example, for this problem, I said try to prove. We've just said example, an example. Now we want to prove that a score is at least 6, 7, 4. So let me tell you something. Here we found an example. We want to find minimum. Until here we proved that answer is 6, 7, 4 or less than that. Now we want to focus on why the answer is greater than or equal 6, 7, 4. So you can say, okay, if you consider N1 plus N2 plus N3 plus N4 equals 2021. And score is N1 plus maximum N2, N3, N4. So we know sum of N2 plus N3 plus N4. The problem finished. Many solutions considered until here, but suppose that it was in round 2. I want to teach you how to prove exactly these problems with exact proof. It will be 2021 minus what? Minus n1. And we know maximum is always greater than equal mean. So it will be n1 plus n2 plus n3 plus n4 over what? Over 3. And then we can say, okay, it is equal to n1 plus 2021 minus n1 over 3. And it will be what? It will be 2n1 over 3 plus 2021 over 3, which will be divided 673 point some decimal numbers. So score, we know it is n1 is at least 0, so it is 673 point some decimal places. So because a score is integer, so a score is at least 674. So we proved also this part, so the answer equals 674. Hong Kong Mathematical Olympiad 2021 problem number 6. Let G be the centroid of triangle ABC if the distance from G to the sides AB, BC, and CA are 20, 12, and 15 respectively. Find the length of BG. For solving this problem, we use some formulas. As I said before, there are around 50 important formulas in geometry. If you want to know all of them and how to solve, they are useful from qualifying level round 1 up to international level. If you want to know them and how to solve problems like this, as I said, feel free to send message to my WhatsApp number in the description and also here. So let's solve this problem. The problem says, okay, it is 20, 12, 15. Now, one important thing in centroids is that we know GM is 1/3 of BG. So GM over BG is 1 over 3. Also, if we draw perpendicular from B, let's see what we have. If we draw this perpendicular, then you can call it Thales theorem, or you can use similar triangles. If we call this one HB, 15 over HB equals this, because triangle, for example, TT prime, triangle MGT is similar to triangle, because they are parallel to each other. Triangle MGT is similar to triangle MBT prime. So you can conclude. Then we can conclude, okay, HB equals 45. Similarly, you can say, okay, 12 over what? 12 over HA is 1 over 3. So HA equals 36. 3 times this, and HC similarly. Also similarly here. HC equals 3 times this, 60. Now, we know area of triangle ABC equals what? Equals A times HA over 2. Or we can write this 2 times this AHA, BHB, CHC. So we can conclude 45, A is 36, HA, 36A equals 45B equals 60C. Now, if we simplify, we divide 3 is okay. It's 3 times 15. So we can divide by 3 and we can conclude 12A equals 15B equals 20C. Here we've used what? When we have centroid, G, for example, the median, GM is 1/3 of the whole median. The next thing we want to find what? We want to find BG. Now, let me tell you one important formula. BG is what? Is 2/3 of MB. MB is median, BM here. So BG squared, the problem says find BG. Okay. BG squared is 4 over 9 MB squared. And there is a formula for MB that is so much important, and it's a result of Schwarz theorem, or you can also prove with other ways. You should memorize that. It's what? BG squared 4 over 9 A squared over 2 plus C squared over 2 minus B squared over 4. And here we understand if we find A, B, and C, then the problem will be solved. For rest of that, we know the relationship between length, so sides of triangle, we can say what? I'll write all of them in terms of A. B is 12A over 15 if we divide by 3, both numerator and denominator, 4A over 5. First one is this. C is 12A over 20. If we divide both numerator and denominator by 4, it will be 3A over 5. And we have A. The other formula that is important is x in terms of ABC. If I want to find x in terms of ABC, it will be what? It will be c squared plus a squared minus b squared over 2a. You can prove it by cos b cos rule here. And now here we want to find x. We know HA is what? HA equals 36. Okay. This is equals what? C. C equals what? 3a over 5. So we say what? We say okay. We know x is this. So if I replace the b and c with the formula in terms of a, c squared is what? Is 9a squared over 25 plus a squared minus b squared, 16a squared over 25 over what? Over 2a. So we want to find x in terms of a. It will be what? It will be 25, 9 plus 25 minus 16 over 2a, and this a squared. 9 plus 25 is what? Is 34. 34 minus 16 is 18. 18a squared over 25 over 2a. We divide this by 2, we divide a and here, so it will be 9a over 25. So we found x in terms of a, we know these things, so we can find a if we use Pythagoras Theorem in this triangle. So HA squared is 36 squared plus x squared, which will be 9a over 25 squared, equals 3a over 5 squared. Now, we want to find it equals what? 36 squared equals, it will be 25 times 25. Here it is 9a squared over 25. We have 25, so it will be 25 times 9. Here 25, 25. And here 9 times 9 minus 9 times 9. So it will be what? And this one a squared. So it will be 25 squared, and if you factor from 9, it will be 25 minus 9, which will be 16. So it is 9 times 16 a squared. So if you consider square root, 36 equals 3 times 4 over 25 a. And you can divide both sides by 12, it will be 3. So a equals what? A equals 75. Now we can find easily b and c. How b we found in terms of a, for a over 5. For a over 5, which it is 15. It will be 60, and c is what? 3a over 5. 3a over 5 will be this over 5 here, 15, 45. So we found a, b, and c, and now we want to find bg. bg was what? Was this formula. So let's copy this. And now we can replace a, b, c with the things we've reached. 4 over 9, 75 squared over 2 plus 45 squared over 2 minus 60 squared over 4. So here we can say, okay, we divide, it is multiple of 3, 3, 3, we divide by 5. So let's see what we have. Then we have, also we multiply by 4. So let's see what we have. 4 over 2 is 2 times 75 over 3 is what? Is 25. 25 times 25 plus 4 over 2, it will be 2 times 9. If you divide by 3, it will be 15 times 15. Minus 4, 4, 1, 9. It will be 20 times 20. So it will be what? The first one will be 50 and 1250. This is memorize the square root until at least 30 squared. It's 225 plus 450 minus 400. It will be what? 450 minus 400, it will be 50. So we can conclude it is 1300. So if we consider a square root, bg equals square root of 1300, it will be 10 square root of 13. Hong Kong Mathematical Olympiad 2021 Preliminary Selection Contest. Problem number 7. Find the sum of all real roots of the equation this equals 16. When we have roots like these, and also this idea is useful for other years of Hong Kong Mathematical Olympiad and also for other countries, you can use changing variable. For example, you say what? You say, okay, I consider this is inside a to the power of 4. We consider it is a and consider it is b. So a to the power of 4 plus b to the power of 4 equals 16. And if you pay attention, we have a relationship between a and b. This idea also useful in SMT Stanford Mathematics Tournament or also Harvard MIT Mathematics Tournament. I released some videos my YouTube channel, you can use them. The relationship is a minus b. A minus b equals 2. So you can say a equals b plus 2. Again, another important idea, when you have a relationship like this and it is possible, try to replace. Here, I can say, okay, b plus 2 to the power of 4 plus b to the power of 4 equals 16. And now if I use binomial theorem, I can say b to the power of 4 plus 4 times 2 times b cubed plus 6, 4 choose 2. 2 squared b squared plus 4 times 2 cubed times b plus 16 plus b to the power of 4 equals 16. You can cancel 16. And if I write here, it will be 2b to the power of 4 plus 8b cubed plus 24b squared plus 32b equals 0. Now we can factor from b and you can divide both sides by 2. So at first divide both sides by 2, then we will have this 12b squared plus 16b equals 0. Then we factor from b cubed plus 4b squared plus 12b plus 16. Another important idea, it's so much useful. If it is a polynomial in terms of b. If the degree is 2 or less than that, we can easily solve and find the roots. For example, if the degree is 2, you can use quadratic formula. But when the degree is greater than 2, one of the most important and useful idea is to find a root, most of the time integer root. For example, check with small answers, numbers. b0, 1, minus 1. So we see that if b is 0, it's positive. Also for b positive, it will be positive. So let's check negative. If you consider negative, the negative 1, then it is even, it is odd, it is not 0. If you consider negative 2, it will be negative 8. For example, if b is negative 2, then we will have negative 8 plus 4 times 4 minus 24 plus 16. It will be negative 8. It will be 16. 16 minus 8 will be 0. So b negative 2, it is 0. So one factor is b plus 2. It's so much useful and useful in, I can say, all years of Hong Kong, around all years of Hong Kong Mathematical Olympiad. So now let's find the rest of that. We have b cubed, so you place b squared here, plus 2b squared, so you place 2b. Now 4b squared is okay. Let's find 12b. We have 4b, so if you place 8, 8b plus 4b. 12b, 8 times 2 is 16, equals 0. Now for we want to find roots. Here the discriminant is 4 minus 4ac. It will be negative 28, which less than 0. So you need to check b equals 0. b plus 2 equals 0. b equals negative 2. b was what? If I want to say b was this term, so let's copy this term. We want to find all roots of that equation. So here we will see, okay, the first one, 2 times fifth root of x plus 1 minus 3 equals 0. So 2 times x plus 1, this equals 3. So fifth root of x plus 1 equals 3 over 2. So x plus 1 equals 3 over 2 power of 5. So we found this part is 3 over 2 to the power of 5 minus the next one. 2 times fifth root of x plus 1 equals negative minus 3 equals what? Minus 3 equals b is negative 2. So 2 times fifth root of x plus 1 equals 1. So fifth root of x plus 1 is 1 over 2. So x plus 1 is 1 over 2 power of 5. So x equals what? 1 over 2 to the power of 5 minus 1. Now, the problem says what? The problem says find what of the roots? Sum of all real roots. So we found 2 roots. We should calculate sum of them. So the answer of this problem will be 3 over 2 to the power of 5 minus 1 plus 1 over 2 to the power of 5 minus 1. So it will be 3, 5 plus 1 over 2 to the power of 5, 32 minus 2. It will be 3 to the power of 5 is 3 times 81. 3 times 81 is what? 243. 243 plus 1 minus 64 over 32. So it will be 244 minus 64 over 32. And it will be 0.68180 over 32. And if we divide, it will be, let's divide both by 2. It will be 90 over 16 and it will be 45 over 8. So the answer equals 45 over 8. Hong Kong Mathematical Olympiad 2021 preliminary selection contest problem number 8. Let n be a positive integer not exceeding 2021 if each of n, n plus 1, and n plus 2 can be expressed as the sum of two possibly the same non-negative integral powers of 2. Find the sum of all possible values of n. Okay, so let's start from n. We say, okay, n equals 2 to the power of a plus 2 to the power of b. Without loss of generality, suppose that a is greater than equal b. So in case 1, we consider if a equals b. So in this case, L will be 2a plus 2a, which equals 2a plus 1. N plus 1 is what? Is 2a plus 1 plus 1. And non-negative integral powers of 2, so 1 is also positive. Okay, n plus 2 will be 2a plus 1 plus 2. So we will see that this number is okay because this 1 is 2 to the power of 0. And it is 2 to the power of 1. It is also 2a. So we see that if n equals power of 2, it will be okay. So n can be what numbers in this case? N can be 1 plus 1, 2. 2 plus 2, 4, power of 2, 8. The last one, because n is not, n is the problem says let n be a positive integer not exceeding 2021. So the last case is 2 to the power of 10, which equals 1, 10, 24, because 2 to the 11 equals 2048. Memorize the powers of 2, they are useful. So here the sum of, it's the problem says sum of, find the sum of all here. Read the problem completely. We don't need number of them, sum of all possible values. So here it will be 248 plus 2 to the 10. It will be 211 minus 2. There are some identities, around 5 basic identities you should memorize. If you had any problem or want to know them, as I said, feel free to send message to my WhatsApp number here and also in the description. So it will be what? It will be 2 to the power of 11. It will be 2048 minus 2, which equals 2046. Now we should consider the case that A is strictly greater than B. Case 2. A is strictly greater than B and equals 2A plus 2B. So let's consider the second number. N plus 1 is 2A plus 2B plus 1. So we know if we want to write it as power of 2x, for example, plus 2y, if x and y are less than A, strictly less than A minus 1, then what we have? Then 2x plus 2y will be at most 2A, and that's a contradiction. If one of them, if x, for example, is greater than equal A plus 1, then what we have? 2A plus 2B plus 1 is at most 2A plus 2A minus 1, because B is at most, we can say A minus 1. Plus 1, here it will be at most 2A plus 2A, 2A plus 1. So here, and also x is, if one of them is at least 2A plus 1, then the other one also is a positive integer, 2 to the power of y. Now here we will reach contradiction, because we proved that in this case n, it is n plus 1. N plus 1 is at most this. Also we know it is 2x plus 2y, which is at least 2a plus 1 plus something, 2y, and it's greater than 2a plus 1. So it is contradiction. We want to say what? We want to say one of them is a, and the other one is less than a, because the other one is less than or equal a. So the things that we found, we don't have a plus 1 or something more than that. So n is 2a plus 2b. N plus 1 is 2a plus 2, for example, c. We have 2a because we said if both of them are less than a minus 1, contradiction. One of them greater than a, contradiction. So they cannot be greater than a plus 1, greater than equal a plus 1. They are less than or equal a. If both of them are not equal to a, we will reach contradiction. So one of them equals a. Now, we say what? For example, we want to consider c here. We say, okay, 2a, we can say 2a plus 2b, it is n plus 1 equals 2a plus 2c. So we cancel 2b plus 1 equals 2c. We know what? We know that here it is 1. It is the only possible case that this equation have answer is when b equals 0 and c equals 1, because the difference of, you can say 2c minus 2b, it is 1. So the only possible case is when b equals 0, c equals 1. So n is what in this case? N is 2 to the power of a plus 2 to the power of 0, 1. Then n plus 1 is what? 2 to the power of a plus 2. N plus 2 is what? 2 to the power of a plus 3. So this is okay. This is okay. We should check that this number should be also okay. We said a is strictly greater than b. In this case, we know b is at least 0, so a is at least 1. So if I want to write it, for example, like 2z plus 2w, we know that what? A is at least 1. So we can conclude that these 2a plus 3 is odd. So here it must be also odd. So one of them is odd, one of them is even. So one of them is 1. So we can say 2a plus 3 is, for example, 1 without loss of generality, z is 0, plus 2 to the power of w. So we can conclude what? 2a plus 2 equals 2w. So 2w minus 2a equals 2. So you can easily, if you write powers of 2, you can easily prove that the only case that the difference is 2 is here. So w must be what? W must be 2. And a must be what? A must be 1. So the first number, n equals what? N equals 2a plus 2b. We've concluded that b must be 0. Also here a is 1. So 2 to the 1 plus 2, 0. It is 3. So n plus 1 is 4. It is okay. It's 2 plus 2. It's 2, 1 plus 2, 0. N plus 2 is 5 equals 4 plus 1. So here the other answer we found is 3 from previous part. We found in some of them 2048. So if we use both of them, 2048 plus 3 from case 2 equals 2049. So the answer equals 2049. Hong Kong Mathematical Olympiad 2021 Preliminary Selection Contest. Problem number 9. In a bag there are 2021 balls numbered 1 to 2021. 2 balls are drawn from the bag at random. What is the probability that the ratio of the numbers of the 2 balls drawn is an integral power of 2? Okay, so we want to find the number of good cases over all cases. So the number of all cases, we can say we want to select 2 balls. It will be 2021, choose 2. Now we want to focus on number of good cases. So one case is you select A2A, one select A4A, A8A, and the last one is A 1024A power of 2 2014A. It's not possible for this one. You say, okay, I should select 2A and then divide it by 2. It will be A. So 2A must be greater than equal 1 less than 2021. It will be the number of cases here will be 2021 over 2. Similarly here you can say 2021 over 4. And the last case 2021, like 2021 over 8, 2021 over, you see, for example, here will be 1. So you should add up all these numbers. Let me tell you a good way to calculate all of these numbers quickly. You use division and say, okay, 2021, when you divide it by 2, you say 10, 10. Again, divide it by 2, it will be 505. Divided by 2. That idea is so much good. You should calculate what this one is in one step. You calculate all of them. It will be what? The next one, it will be 2, 10, 5. It will be 2. This one, then you divide again by 2. It will be 1, 2, 6. You divide it by 2. It will be 63. You divide it by 2. It will be 31. You divide it by 2. It will be 15. Let me move it to have enough space. Divided by 2, it will be 7. Divide by 2, it will be 3. And divide by 2, it will be 1. 1 is exactly for this. So we should add up all these numbers over all cases. So let me write all of them. 1 plus 3 plus 7 plus 15 plus 31 plus 63 plus 126 plus 252 plus 505. And the last one is plus 10, 10. So if we add up all these numbers, it will be 10, it will be 11, it will be 6, 4, 46, it will be 7, 557, these two numbers, 9, 6 to 8, 1, 8, 9, 1 we have 14, 2, 4, 6. If we consider these two numbers, they will be 5, 1, 0, 5, 1. And if we consider, let me write these two numbers, they will be 8, 5, 4, 9, 2, 2, 4, and then it will be 13, 1, 11, 1, 10, 1, 20, 13. So the answer will be 2013 over 2021. Choose 2 all cases. We should select 2 of them. So the last thing we should calculate is what? 2021 choose 2. It will be 2021 times 2020 over 2. It will be 2021 times 10, 10. So if we want to multiply them, 2021, 10, 10. Here we can ignore 0 and then consider 1, 0 here. It will be 1, 2, 0, 2, 0 here. So you should write this. It will be 1, 2, 1, 4, 0, 2. So it will be 2, 0, 4, 1, 2, 1. Now the last answer will be what? 2013 over 2041210. The last answer is exactly this. Hong Kong Mathematical Olympiad 2021 Preliminary Selection Contest Problem number 10. A teacher wants to set some questions for tests on addition. Each question must involve adding a pair of two-digit numbers, positive integers, possibly the same, and no carry may be involved in the process. The answer must also be a two-digit number. How many different questions can the teacher set? The result of swapping the order of two different numbers is regarded to be a different question. For example, 12 plus 34 and 30 plus 12 are regarded as two questions. Okay, so let's consider the digits are A, B, and the next one C, D. We want to add them. B plus D is at most 9. A plus C also is at most 9, but the difference is there are ones digit, there are tens digits, so A and C are at least 1, but B and D can be at least 0. So here we want to consider at first B and D, and they are not related to each other. So we want to find the number of cases B and D, and then A and C, and then multiply them. So at first, let's focus on B and D. If B is 0, then D can be what? 0, 1 to 9. If B is 1, D can be what? 0, 1 to... If it is 9, 9 plus 1, 10. We have carry. So until what? Until 8. So if B is 2, then it's from 0 to 7 until... If, for example, B is 8, D can be 0, 1. If B is 9, D can only be 0. So if we want to count the number of cases for B and D, we have 10 cases here, 9 cases here, 8 cases here, and here 2 plus 1. So it will be 10 times 11 over 2, which will be 55. Now we want to count the number of cases for C and D. C0 is not possible because tens digit here. Let's consider A and C. For example, let's start with A. A and C. If A is 1, C can be 1, 2 to 8. 9 is not possible. If A is 2, C can be 1, 2 to 7. Until if A is 8, C can be only 1. If A is 9, C it cannot be 0, and it's impossible to select a number for C. So we have here 8 plus 7 plus 6 to 1. It will be 8 times 9 over 2 for 36. So we should multiply 55 times 36. We can say what? For example, we can say to consider 110 times 18. So let's consider it's 18 times 18. It will be 1980. So the answer equals 1980. Hong Kong Mathematical Olympiad 2021 Preliminary Selection Contest Problem number 11. Suppose 21x plus 20y to the power of 2021 plus x to the power of 2021 plus 484x plus 440y equals 0 for some non-zero real numbers x and y. Find x over y. So let's see what are these things. You can say, okay, this plus this, the power is odd, so we can factorize, because if n is odd, then an plus bn equals a plus b, an minus 1 minus an minus 2b plus an minus 3b, and the last terms will be plus bn minus 1, previous term will be negative a, b, and minus 2. Okay, here we can use this, and let's see what we have. We can factorize here from 20. We can say, okay, if we consider this plus this, it will be 21 x plus x, 22x plus 20y. And for example, let's consider this number c. It will be c to the power of 2020 minus c to the power of 2019 times x plus c to the power of 2018 x squared. And the last terms will be plus x to the power of 2020, and previous last term will be negative c to the power of 1, x to the power of 2019. So it will be this plus this number. So if we check, we will see 484 is 22 squared. So if you factor from 22, it will be 22x. And if you factor 440 is what? 440 is 20 times 20. So we can say, okay, it's plus 20y equals 0. Now that's good because in both of them we have 20x plus 20y. So we say, okay, 20x plus 20y equals all these terms, c2020 minus c2019x plus c2018x squared, 2 minus cx2019 plus x2020 plus 2020 equals 0. So 1, it is 0, or this one is 0. If this one's 0, case 1, 2020x plus 20y equals 0. So we want to find x. Here the sentence of the problem, x over y. The problem is what? The x over y is what? We can say, okay, 22x equals negative 20y. So x over y is negative 20 over 22. Negative, divide both sides by 2, negative 10 over 11. Because the problem says only find the answer of this, so you find the answer and the problem will be finished. But for example, suppose we want to prove exactly, and it was, for example, a problem of round 2. If you don't consider the case 2, you will lose more than half of the marks. So let's consider, I want to prove that the second bracket cannot be equal to 0. At first, I want to say this part is always at least 0. So let's prove this. I say, okay, if I consider this number, 29x plus, let me write more numbers, x squared minus c 2017 x cubed plus c 2016 x squared plus 2 numbers, let's start from here, x 2020 plus cx 2019 plus c squared x 2018 minus c cubed x 2017 plus c to the power of 4 x 2016. It equals 0. Now I want to, it is not equal to 0. I want to prove why it is greater than equal 0. So one way is to do what? Consider c 2020 minus this. So if I consider this one and factor, so at first I consider, let me write the rest of that by black. It will be c 2019 c minus x. The next one we factor from c 2017 x squared. Again, it will be what? It will be c minus x. And for example, this term I factor from what until here and here. Okay, it will be c cubed x 2016 c minus x plus c x 2018 c minus x plus x 2020. We want to say why it is greater than equal to 0. If the power of x is even, if c minus x is at least 0 and c is at least 0, then the problem will be proved. You can use the same things. Here we didn't consider x 2020. If you don't consider c 2020 and consider from, let me write with pink, if you consider this number until this number, you can conclude that if x minus c is greater than equal to 0 and x greater than equal to 0, then the problem will be solved. So let's see what cases are left. If c minus x is less than or equal 0, and here also if you say c minus x less than or equal 0, and again c is less than or equal to 0, it will be solved. So without loss of generality, we can consider the case that is left is c minus x is at least 0 and c is less than or equal to 0. The case that both of them are 0, we can prove this Also, if one of them equals 0, again, we can prove this. So let's consider the case that it is strictly greater than 0 and it is strictly less than 0. Now we want to prove in this case why this number is at least 0, this term's expression. So I can consider c is greater than x less than 0. So here I say c to the power of 2019 because the power is odd is greater than x to the power of 2019. Also for other odds. So if I consider this expression, for example, t, then t is greater than c minus x times c minus x is positive times you replace c to the power of 2019 x to the power of 2019 plus again x squared is greater than c to the power of 2017 is greater than x to the power of 2017, so you can say x to the power of 2019 c minus x, and you can write it until again x to the power of 2019 c minus x plus x to the power of 2020. So if you want to see how many terms do we have, x0, x2, so here we have around 20. If we consider, if we expand, we have from C 2020, then C 2019, C 2018, we have from 2020 to 0, we have 2021 cases. We subtract by 1, 2020. Then we divide it by 2, it will be 100, 10, 10. So here it will be equal to 10, 10, c minus x, x to the power of 2019 plus x to the power of 2020. Then if we expand, it will be 10, 10, cx 2019 minus 10, 10, x to the power of 2020 plus 1 times this. So it will be minus 1009 x to the power of 2020. And we know c is greater than x. So we can say what? We can say, let's see, we factor from x 2019. It will be 10, 10 c minus 1009x. We know c is greater than x, so you can say x 2019, c is greater than x, so it will be greater than 110x minus 1009x. So it will be great x here, so here it's x 2020, and we said that x is a negative number, it's not 0, so you can also say it's, in this case, it is strictly greater than 0 because the power is even. So we proved that t, if we consider all cases, t is at least 0 here, so it is t plus 2020 is always 22, t plus 22 is always positive, so the only answer is this. This was the proof if, for example, if we see this problem in round 2 national level or higher levels. If you had any question of the proof of this problem, as I said before, send message to my WhatsApp number in the description, and also Hong Kong Mathematical Olympiad 2021 preliminary selection contest problem number 12. In this figure, OABC is a trapezium with OC parallel to AB here, and AOB angle AOB equals 37. Furthermore, ABC all lie on the circumference of a circle centered at O here. The perpendicular bisector of OC meets AC at D if ABD, this angle equals X, find X. So we consider, for example, this angle equals beta. So because they are parallel, this angle also equals beta. It is perpendicular bisector, so these triangles are congruent, so this angle also equals beta. Also, we know OC, OA both of them are radius, so OCA is an isosceles triangle, so it is beta. It is also equals beta. Now we say, okay, this is beta, it is inscribed angle, so this arc is twice inscribed angle. If you don't know, you should search inscribed angle, central angle, interior angle, exterior angle. They are useful in many problems. Or if you had any question, as I said, feel free to send message to my WhatsApp number in the description. Now it is 2 beta, it is central angle, so it is 2 beta. Here is beta, so it is also beta. Now we can conclude, because this is beta, so ODBA is cyclic. Cyclic because these two angles see the same side. And now here, because it is beta, we can conclude also this angle is beta. Now if we consider triangle OAC, we have what? 1 beta, 2 beta, 3, 4 beta. 4 beta plus 37 equals what? 180 degree. So 4 beta equals 180 minus 37 over 4. It will be what? 10 minus 7, 3. 7 minus 3, 4. 1 over 3 over 4. And now we can consider, for example, this ODBA, that is cyclic. Sum of opposite angles equals 180. So here x plus beta. X plus beta plus 37 is 180 degree. Now if we replace x beta with 143 over 4 plus 37 equals 180. So we can say, okay, x equals 180 minus 37 is 143. 143 minus 143 over 4. So we can factor from 143, 1 minus 1 over 4 is 3 over 4. We should calculate that. It will be, let me write 339. Okay, over 4, it will be 1, 0, 29, 7, and 1. Then you have 10, 2, 25. So the answer equals 107.25. Hong Kong Mathematical Olympiad 2021 preliminary selection contest. Problem number 13. Find the smallest positive integer n such that the last 4 digits of n cubed from left to right are 2, 0, 2, 1. When you have last 4 digits, for example, when you have last digit, it means mod 10. When you have last 4 digits, you should consider mod 10,000. Now here you say, okay, n cubed mod 10,000. Sorry, mod 10,000 equals 2021. Now you split 10,000 to two numbers that are coprime, means what? You can conclude n cubed, and it is equivalent. N cubed mod 2 to the power of, it is 10 to the power of 4. 2 to the power of 4, 16 is 2021. And n cubed mod 5 to the power of 4, 625 equals 2021. So let's at first, we want to find n is what for each case. For example, n is what to reach mod 16, these numbers. So at first we say, okay, n mod 2 is 1. It's obvious, because if n is even, then it is even. Then you say, okay, n mod 4 is what? This number mod 4, you need to consider only last 2 digits is 1. We know it is it's a very famous theorem that if n is odd, then n squared is the next one we should consider. N squared. Oh, sorry. And we should consider n cubed always. N cubed is this, so n cubed is 1 mod 4. Now we want to find n is what mod 4. So let's see. I wanted to use for squares. Here we have cubes, sorry. So let's solve this one. N cubed is 1 mod 4. We want to find n mod 4 is what? N mod 4 can be what numbers? 0, 1, -1, or for example 2 and 3. So if we want to write easier, 3 will be -1. So n cubed for this one, n cubed here, it will be 0, it will be 1, it will be 2, 8, 8 is also 0. It must be odd, we said. So negative 1, you need to only check 1 and negative 1. Negative 1 cubed will be negative 1, and that's not good because it is 3. So we conclude that n mod 4 must be 1. Now, you can use many things. For example, let me tell you one way. You can say here, you can consider mod 8 and mod 16, or one other way is you can consider 4k, n is 4k plus 1. So n cubed is 4k plus 1 cubed. So I want to consider mod 16. If you consider mod 16, then let's see what we have. 1 plus 3 times 4k plus 3 times 4k squared. The other numbers or multiple of 16. So it is mod 16 is 2021. If you divide 2021 by 16 and want to see the remainder is what? 1, 16, you have, let's consider 42, and then 2 times 14, 16, 32, 10, 101. Then you consider 6 times 16, 96. The remainder equals 5. So we understand what? We understand 1 plus 12k is 5 mod 16. So you say, okay, 12k is congruent to 4 mod 16. You divide both sides by 4, it will be 3k mod, because 16 over GCD of 16 and 4, which is 4. Then you can say, okay, negative k is 1, so k is negative 1. It is mod 4 is 3. Now we say, okay, k is 4q plus 3. Now we can conclude n is 4 times k plus 3, which is 4q, plus 3 plus 1, which is 16q, plus 13. Sometimes only mod are useful. Sometimes these types of number are useful. For example, for LT, lifting the exponent. This idea is useful to consider this, but sometimes you can use both of them to reach an easier solution. So we found that n mod 16 is 13 or negative 3. So let's consider now on 25 on 5 to the power of 4, 6 to 5. So we know n to the power of n cubed equals 2021 mod 6 to 5. So at first let's consider n. We want to find mod 5 is what? In n cubed is 1 mod 5. So if we consider n mod 5, it can be 0 plus minus 1 plus minus 2 mod 5. And for each of them, n cubed, it is 0. It is not good. For this one, positive 1, negative 1, you should only select positive 1. It will be positive 8. Positive 8 will be 3. Negative 8 will be 2. All of them are bad. So we can conclude n mod 5 must be positive 1. Now let's consider mod 25. N cubed mod 25 is 2021, and it is congruent to 2000. Is multiple of 25, so it will be 21. And okay, so we want to see that n mod 25 can be what numbers? Because n mod 5 is 1, so you need to only consider 1. 1 plus 5, 6, 11, 16, and 21. So also you can say it's 6, 11. Instead of 16, you can write negative 9. Instead of this, negative 4. Now, if we consider n cubed, it will be 1 here. It's not good. It will be 36. Oh, no. 6 cubed. 6 cubed will be 6 times 6 times 6. 6 times 6 is 36. 36 mod 25 is what? 5 plus 11. So it is 66. 66 will be 16 mod 25. And that's bad because we want to reach 21. The next one, 11 cubed. 11 times 11 times 11. 11 times 11 will be 121. If you consider mod 25, it will be 21. 21 times 11, because it is not 1, You can easily prove that it is not 21, but if you want to write it will be 21, 231 mod 25, it will be 31 or 6, and that's again bad. About -9. It will be -9 times 9 times 9. 3 negatives will be -9 times 9, 81. 81 mod 25 is 6. 6 times 9 is 54. So it will be -4, and -4 is 21. So -9 is good. Let's check also -4. Maybe we have more than one answer. -4 times 4 times 4, it's 64. So it will be -14, or mod 25. It will be 6, 5, 11. So it is also bad. So we've concluded that n is -9 or 16 mod 25. Now we want to find mod 625. The rest of that we use the new idea that also previous part we've used. We say, okay, n equals 25, for example, k or k1 plus, because we've used k1 plus, let's write -9, it's smaller. And this n cubed is this cubed. If we consider mod 625, then let's see what we have. It will be -9 cubed, and then plus 3 times 9 squared, 25k1. And the rest, the other terms will be multiple of 625, and it must be what? Mod 625, 2021. So let's calculate and see k1 should be what? We have 39 squared times 25k1. It is 2021 plus 9 cubed. 9 cubed is 729. If we add up, it will be 0. We have 1, 2, 2, 4, 5, 7, 2, 7, 5. Now, if you divide both sides by 25, because it is mod 625, if you divide, it is multiple of 25, because the last two digits is multiple of 25. So mod will change to 25, 625 over GCD of 625 and 25. Mod 25, then we have what? 3 times 81, K1. If you divide by 25, it will be 1, 25, 1, 0. And now, here 81 is what? Mod 25, it will be 75, 6. 18, K1, mod 25 is 10, mod 25. We divide both sides by 2, so 9K1 is congruent to 5, mod 25. So the next one you multiply by 3, 27K1 is 15 mod 25, and then it will be 2K1 is 15. You multiply it by 12, so it will be negative K1 because it is 24 multiplied by 12, and it is 12 times 15. If you consider this mod 25, it will be 3. We can say it's 6 times 30. So 30 mod 25 is 5, is 30 again. So it will be 5. It will be 5 mod 25. Now, K1 then is what? K1 is -5 mod 25. Now we say what? We say n is 25 K1 minus 9. N is 25 K1 minus 9. And K1 is what? K1 is 25 Q1 minus 5 minus 9. So it will be what? It will be 625 Q1 minus 125 minus 9, which will be 625 Q1 minus 134. Now we should find n. So let's write the things that we've reached so far. N mod 625 is -134 mod 625, and n mod 16 equals, let's see what we've got. Mod 16 was here, -3. -3. Now we want to find n mod 10,000. Okay, so if we calculate this, we can say, okay, because it's greater, it's good to replace in the second one. We say n is 625, for example, t minus 134 is congruent to negative 3 mod 16. Now, if we consider 625, if we divide it by 16, it will be 348, 214, 145. It will be 8, 9. If you divide by 9, yes, we can multiply by 9. Let's check my answers. Okay, it will be 1. So this number mod 16 is 1, so t is 134 minus 3 is 131 mod 16. And we can say, okay, t is what? T is 16. W plus 131. We can reach a smaller number if we divide 131 by 16. It will be what? It will be, if you multiply by 8, yes, the remainder will be what? Will be 3. So it will be 3. So you can say t is 16w plus 3. So n is 625 t 16w plus 3. And sorry, t, we replace t with this, so it will be 16w plus 3 minus 134. And if we consider mod 10,000, here it will be 0, so we should calculate 3 times 625 minus 134, which equals 7 minus 134. So 5 minus 4, 1, 7 minus 3, 4, 8 minus 1, 7, and it will be 1741. And the problem said find the minimum number, minimum positive number n. Let me. So here, like, find the smallest positive integer n. So if you consider this number, n mod 10,000 is this. So the minimum positive integer that satisfies this is exactly 741. Hong Kong Mathematical Olympiad 2021 preliminary selection contest, problem number 14. There are 21 students in a class numbered 1 to 21. In each lesson, 3 students are responsible for preparing notes, and among them, the one whose number is in the middle will give a presentation to the class. At the end of the academic year, it was found that for any 3 students, they have been preparing notes together exactly once. What will be the sum if we add up the number of the student giving presentation in each lesson? So here, for example, if you want to see how many times we count 1, 1 is not middle because it's minimal. But if you want to see how many times we count 2, because we sum all of them, 2 times the number of ways that 2 is in middle, so you should select 1 smaller than this, or one number from 3 to 21. So it will be what? 1 times 21 minus 2, 19. And for example, if you want to find how many 3's do we have, 3 times the number of them, 1 to 3, you should select 2 to 4 here to 21. Here we have 18. So 2 times 18 and so on until the last part 20. If I want to write the sigma, I equals 2 to 20. Then you say I minus 1 before that, and 21. So if you select I1 to I minus 1 here, and I plus 1 to 21. So it will be 21 minus I. You can select it will be 21 minus I. Or you can say 21 minus I plus 1 plus 1. It will be 21 minus I, and you can see that it is 2, it is 1. 21 minus 2, it is 3, 2, 21 minus 3, 18. And now here we use 2 important identities for solving that. Around 6 important identities we have. If you want to know all of them, as I said, feel free to send message to my WhatsApp number in the description and also here. So If I want to write, I say, okay, it's sigma I equals from 2 to 20. If I expand this, it will be I here will be negative I squared. 21i plus I will be 22i minus 21. So it will be negative I cubed plus 20I squared minus 21i. So we should use three important formulas. The first one, in all of them we consider 1 to 20 and then we subtract. The first one is negative 2 cubed. Let me factor from negative 2 cubed plus 3 cubed to 20 cubed. And the next one is 20 2 squared plus 3 squared plus 20 squared. And the last one is negative 22 plus 3 to 20. And here you can say, okay, I consider from negative 1 to 20, it will be 20 times 21 over 2 squared. So we add 1 and then we subtract 20, the next one. It will be 20 times 21 n times n plus 1 times 2n plus 1 over 6. Look, the ideal identities are these. N times n plus 1, memorize. 2n plus 1 over 6. And the next one, 1 cubed to n cubed equals n times n plus 1 over 2 squared. Here we've used 1 to n is n times n plus 1 over 2, you know. That is what? 21 times 41 over 6. We add 1 squared and then subtract 1. 21, and the last one is 20 times 21 over 2 minus 1. Now we should calculate these things. Okay, so let's see what we have. It will be negative 210, negative 210 squared plus 1. And here, if we divide by 6, here we have 10, we have 7. And it will be plus 20 times 10 times 7 times 41 minus 20. And this one, we say, okay, negative 20 times 210 plus 21. Here is minus. Okay, so let's read and make sure it's correct. Okay, so in this case, we want to calculate. We will see this part. 210 squared is easy because 21 is 441 minus 441 0 plus 1. Also, this part will be negative 44110. So the only case we should calculate is this. So it is 7. It is this. So 22 times 287 is 15475. Will be 4, 11, 13, 6. Okay, so it will be plus 1 plus 63140 minus 21 plus 21 is minus 1 minus 4410. You can cancel these numbers and then it will be what is 63140. You should add up these two numbers, 44100, 4410, so it will be 01584. So it will be minus 48,510. Now if we subtract, it will be 0, 1 minus 4, 4 minus 1, 3, 11 minus 5, 6, and then it will be 2, 12 minus 8 will be 4, and here 5 minus 4, which will be 1. So the answer equals 14,630. Hong Kong Mathematical Olympiad 2021 Preliminary Selection Contest. Problem number 15. There are some proper fractions. Proper fraction means that it is strictly less than 1. And with the following properties, the numerator and denominator are 2-digit positive integers with exactly 1 digit in common, and this common digit is non-zero. When this common digit is removed, the result is equal to the original fraction in lowest term. An example is 16 over 64. So if we will remove these two 6, it is 1 over 4. 1 over 4 equals 16 over 64. Find the sum of all such fractions. Okay, so we should consider different cases. For example, if we have AB and AC, we have exactly one digit in common, so B is not C, and our two-digit number A is not 0, and this common digit is non-zero, so A is not 0. And when this common digit is removed, fraction in lowest term. Okay, so now let's see what we have here. Then it equals what? It equals, at first we should check, it should be equal to B over C. Because when we remove that, so it will be what? 10A plus B equals 10A, and also it is proper fraction. We should pay attention. B is less than C, strictly less than 10A plus C equals B over C. So if we cross multiply, 10AC plus BC equals 10AB plus BC. You can cancel BC from both sides, and A is not 0, so you can cancel both sides by 10A. C equals B, but it is proper fraction and it's contradiction. And so case 1 is the case that the two common digits are in 10th digit. Now let's consider case 2, that for example we have D, E, and also F, E. In this case the commons are in here, and it equals D over F. D is less than F, D is not 0. So let's check this case. It is 10D plus E, 10F plus E equals D over F. So if we cross multiply, 10DF plus EF equals 10FD. And here the problem says it is equal to fraction in lowest term, for example, like 1 over 4. At first we say B over C, and then if it is equal, then if we found an answer, at the end we check, is it in the lowest term or not? We know if something equals B over C in lowest term, it is also equal to B over C. Now this case, 10FD plus ED. So if we cancel this EF ED, we can say, okay, EF equals ED. So we have two cases. If E is 0 or F equals D. So F equals D is impossible. The problem says the common digit is non-zero, so E is not 0. So here also it is contradiction. Now we've reached contradiction for these two cases. We should consider two other cases. Case 3. Okay, we want to use different variables. EF, okay, GH, for example, IG equals H over I. We know G and I are not 0 because they are two-digit numbers. The common digit is G is not 0, and we know that it says they have only one common digit. This common digit here the problem says with exactly one digit in common. And here you can say, okay, also I cannot be G, I, and H are different. So let's open this on here. It was better to draw a line like this, and also for these two parts. Okay, if we write, it will be 10G plus H, 10I plus G equals H over I. If we cross multiply, then we have 10GI plus HI equals 10IH plus GH. If we simplify, we will reach 10GI equals 9IH plus GH. It is a proper fraction, so I want to say if G equals I, then we have more than only we have these two common digits, so I is not equal to G because it is proper fraction. I is greater than G. So let's consider some cases of this number. We know G, I, and H are digits. So for example, we can say 10GI, maybe I is not 0, G is also not 0 because it's common point. So we can say 10GI is strictly greater than 9GI. And here H maybe is 0, okay, but so we can say, okay, 9IH is strictly greater than 9GI. So we can say G is less than H, the first thing that we've reached. And then let's see what other condition we can conclude. So let's write the rest of that with black. We can consider it is greater than, because H greater than G, it is greater than non-GI plus GH. So if you subtract, GI is greater than, we've replaced I is not 0, we've replaced H with G, and H is greater than G. So here we can say, okay, here we replace H with G, I is not 0, so we can say what? We can say 10GI minus 9GI is GI greater than GH. So G is not 0, we can conclude I is greater than H. So I is greater than H, H is greater than G. Now we can say what? 10GI, write it GI plus 9GI and take it to the right hand side. It will be 9I H minus G and plus GH. We know H is greater than G, so it is positive. It is at least 1. And then we can say, okay, it is H is not 0, G is not 0, means greater than 0. So we can conclude what? We can say, okay, it is strictly greater than 9I. So if you divide both sides by I, you will reach that G is greater than 9, and that's a contradiction. And that's a contradiction because G is a digit. So we've reached this. GI is 9I. We've written 10GI, 9GI plus 9GI. Take it to the right hand side. 9IH minus 9GI. Then plus GA. It is at least 1 by the things we've reached here, greater than 9I. So G is at least 9, and again contradiction. So let's consider the last case. Case 4 is GH. IJ, we consider JK, and here KL. And we want to see under what condition it will be equal to J over L. Because there are two-digit number, J and K are at least 1, because and K also is 1 digit. And J, if JK are equal, so we have more than one common digit, so we can say J is proper fraction, J is less than K. Now, if I write it, it will be 10J plus what? Plus K equals 10K plus L equals J over L. Now, if we cross multiply 10JL plus KL equals 10KJ plus LJ. And if we simplify, let's see what we have. 10JL, we have 9 LJ or JL plus KL equals 10 KJ. Now here we have 9, here we have 10. So if we consider mod 9, let's see what we have. Then KL is congruent to KJ mod 9. So then we want to, so let's see, K here is what? We know K is here and K is greater than J. So we should consider different cases. Maybe K equals 9, and we know it is always correct. Maybe K equals 6, maybe K equals 3, or also maybe K and 3 are coprime numbers. Their GCD is 1. So in this case, you can divide by K. L is congruent to J mod 9. So L is J. Can L and J be equal? No, because they are the only cases, K only, they have these two numbers. The problem is from assumption of the problem. The only common digit is K. So here we conclude L and J, one of them is 0 or 9. The other one you should select 1. 1 and 10 is impossible. So one of them is 0, one of them is 9. Now if I want to consider this case, let me copy this one and see what we have. So L and J cannot be 0, so J is 9. And if L equals 0, now K is what? The GCD of K and 3. Because it is a proper fraction, J is less than K. So when J is 9, it is impossible. So we've reached contradiction for this case. Now let's consider these three cases. So the first case, when K equals 9. If K equals 9, then let's see what we have. 9LJ plus 9L equals 90J. And if we divide both sides by 9, then LJ plus L equals 10J. Then in this case, we can factorize. We can say L minus 10, J minus 10J we have, plus 1, it equals what? It equals negative 10, or you can say 10 minus L times J plus 1 equals 10. So we should consider different cases. J plus 1, if it is J is at least 1, so it is at least 2. So it can be 2, it's 5, or it can be 10 or 5 2, or 10 1. So we have three different cases. Let me move them to the bottom here and move these two cases. Okay, so the first one is L equals 5, J equals 1. The second case, L equals 8, J equals 4. The next one, L equals 9, J equals 9. And because we have, then our number is what? JKKL. JKKL. So J and L cannot be equal, and K is what? 9. So the first one, J is 1, K is 9, 19 over KL, 95. So if we remove them, it will be 1 over 5, and we see, yes, it is correct. So we found one answer, 1 over 5, the first one. Here, JKKL, it will be 49 over K is what? 98. It will be what if you cancel these two things? It will be 4 over 8. It is equal to 1 over 2. But it is not in the lowest term, because 4 over 8 is not in lowest term. So we found these two cases for K9. Now let's consider the case that K equals 6. So let's move the other ports bottom. So in this case, K equals what? In this case, K equals 6. Now, if we consider this equation here, 9LJ plus KL, 9LJ plus KL, which is 6L, equals 10KJ. 10KJ is 60J. Now, we can say, okay, if we divide both sides by 3, we have 3LJ plus 2L minus 20J equals 0. So here, for example, one way is to consider all cases of J, but we know what? We know here 3L, if L is small, for example, if L is 1, then 3J minus 20J is negative 17J. And then you have 2L here. So if we consider L, it is even, so this must be also even. So L is even or J is even. At least one of them is even. So let's check, for example, some example. If L is 1, Then we have 3j minus 20j negative 17j plus 2 is 0. So we see that it is what? It is impossible because 17j equals 2. 17j equals 2. The next case, if L equals 2, for example, you can say, okay, negative 14j plus 4 equals 0 if L is 3. So you will understand that the coefficient here, if you consider, it is j3L minus 20 plus 2L equals 0. So you can say j equals 2L over 20 minus 3L. So j is not negative, and also our fraction is this. J is at least 1. So you can conclude, let me move this part to the bottom. Okay, so we can say what? We can say it is at least 1. So 2L is at least 20 minus 3L. So 5L is at least 20. L is at least 4. So if we check, for example, L equals 4, then let's see what we have. J equals what? Equals 8. 20 minus 3L minus 12, which is 1. So let's check this one. Let me copy our fraction here. So in this case, J is what? 1. K is what? 6. 6. L is what? 64. So if you remove 1 over 4. So the problem also said this. So one answer we found, another one. Now let's check other cases. We've checked until L equals 4. L equals 5. Then J equals 10 over 20 minus 15. 5. So it equals 2. So if we will consider JK over KL, it will be 26 over 65. If you replace it, will be 2 over 5. And it is another answer. It is also in lowest term. So let's check the other one here. L equals 6 because K only one common digit we have, so we reject that. L equals 7, so J equals this formula 14 over 20 minus 21. So it will be negative from L greater than 7 because 20 minus 3L must be positive, at least 1. And okay, so we don't need to check rest of that. So case 6, the last case we should consider is when K equals 3. So let me cut this part and paste it here. Okay. Now for K3, if I want to write our main equation, we have what? We have this. I should see. Okay. If I replace K with 3, then I have 9LJ plus 3L equals 30J. So we can say 3LJ plus L equals 10J. And then we can say, okay, so J is what? J is L equals J 10 minus 3L. So J equals what? L over 10 minus 3L. So 10 minus 3L is greater than equal 1. So 3L is at most 9. So L is at most 3. So we should check only L1, L2, L3. L1, so let's write at first L1. So J equals 1 over 10 minus 3, 7, contradiction. If L equals 2, then J equals 2 over 10 minus 6, which is 2 over 4, contradiction because it is not digit. The last case. If L equals 3, then J equals 3 over 10 minus 9, which equals 3. And because K equals 3, J cannot be equal 3 because K is not equal J. So our fractions are 2 over 5. Let me write with black. 2 over 5 plus 1 over 4 plus Then once we found another answer, 1 over 5 here. If we add up these fractions, 20, it will be 8, it will be 5, it will be 4. So the answer equals, the problem says find sum of these fractions. The answer equals 17 over 20. Hong Kong Mathematical Olympiad 2021 preliminary selection contest problem number 16. How many of the first 2021 positive integers can be expressed in the form a cubed plus b cubed plus c cubed minus 3abc, where a, b, c are non-negative integers? We have an important identity for this part. A cubed minus plus b cubed plus c cubed minus 3abc equals a plus b plus c times a squared plus b squared plus c squared minus ab minus ac minus bc. Okay? And this part also you can write it with two other different forms. For example, one of them you can say a plus b plus c squared minus 3ab minus 3ac minus 3bc, or you can write it a plus b plus c. You can say a minus b squared over 2 plus a minus c squared over 2. Or you can factor from 1 over 2 if you want. I can write 1 over 2 a minus b squared plus a minus c squared plus b minus c squared. Now, here, one of the most important things that's useful from round 1 to IMO level, considering some small examples. See, can we create one? It says positive integers from 1 to 2021. So, for example, can we create one? A, B, C are non-negative integers. So, for example, if A equals B equals C equals 0, so it will be 0. If two of them are 0, one of them is 1, then it will be 1 times 1 over 2. If I use this, 1 plus 1. A minus C, B minus C will be 1. It will be 1. So we can create 1. Now, for example, if you want to create 2, you can say A0, B equals C equals 1. So it will be 2, 1 half, 1 plus 1. Here it will be 2. Now, let's try to create 3. If we want to create 3, 3 divides A plus B plus C, or 3 divides this part. Here we use this form. If 3 divides one of them, A plus B plus C, then 3 divides this, and also 3 divides this, so 9 divides this. So we can say, let's call this one T. If 3 divides T, we can conclude by, let me call this one star. Then by star, you can conclude that 3 has to divide A plus B plus C, because also if 3 divides this, 3 you can subtract this, and 3 divides A plus B plus. So 9 divides T. So V3 is maximum power of 3 in T is at least 2. So for 3 we prove that it is not possible. Now for 4, for example, so as we can see, we select some equal numbers. For example, if we select A equals B equals C, it will be 0. If we select, for example, A like this, A equals B equals, for example, W, C equals W plus 1, then let's see T equals what? It will be 2W, 3W plus 1, and then 1 half, 1 plus 1, it will be 3W plus 1. If A equals W, like it was like we create 1, A, B, C, So here it was 4, 2. It was okay. If A equals W, B equals C equals W plus 1, then we have what? T equals 3W plus 2, 1 half, 1 plus 1, which equals 3W plus 2. So we have what? We have, we proved that we can create 3W plus 1 and 3W plus 2. But now we should see how we can create the case that 9 divides T. So let's here see how we can create 9. Let me consider this one. For example, if we select 0, 0, 0, 1, 0, 1, 1. If we select 1, 1, 1, it will be 0. If we select 0, 1, 2, then it will be what? It will be 3 times 1 half. 1 plus 1 squared again plus 2 squared, which is 4. 6 over 2, 3, 3, 9. So we can guess that 3 consecutive numbers. So here, if we select AW, BW plus 1, CW plus 2, then T will be what? Will be 3W plus 3, and 1 half, 1 squared plus 1 squared plus 2 squared, which is 4, and we have 3W plus 3, 6 over 2 is 3, so it will be 9W plus 9, so it is 9W plus 1. So you can create all numbers multiples of 9. So you should say 1 to 20, 21. The only numbers that are bad are multiples of 3 that are not multiples of 9. We 3, 20, 21 minus the numbers that we 3 of them equals 1. So you say 20, 21 minus multiples of 3. Then you should add, if you consider, or you can say like 2021 over 9. So you subtract the numbers that are multiple of 9. So here V3 is 1. Now if we calculate that, it will be 2021 minus 2021 over 3, 6, 22, 7, 11, 3 plus over 9. 2 times 9, 18, 22. 2 times 9, 18, 41. 3 or let's check 2, 18, 22, 2, 41, 41, 4. Now let's calculate this number. We can say this plus this will be 5. 2 plus 2, 4. 0 plus 2, 2, 2, 2. 4, 5 minus 6, 7, 3 will be 2. 14 minus 7 will be 7 and then 1. 11 minus 6, 5 and then 1. So the answer equals 1572. Hong Kong Mathematical Olympiad 2021 Preliminary Selection Contest. Problem number 17 star says this question was cancelled in the contest due to a misprint in the original question paper. Okay, so let's read the problem. In triangle ABC here, BAC is 60 degree here, this angle. And M is a point on BC. Gamma is the inscribed circle of ABC, triangle ABC, which touches side BCCAAB at DDEF. AM meets gamma at P and Q. AP is less than AQ, okay? If AE equals 4, A is 4, so it is also 4. EC2, it is also 2. AP equals QM, AP equals QM. Find the length of AM. So at first, I want to prove that MD is also 4. How can I say that? I say, okay, MD squared equals MQ times MP. The problem says MQ equals AP, so you can say AP. So MP is also AQ. Because MP equals, look, for example, you can say it is X, it is Y, it is X. You can say MQ is what is X, MP is what X plus Y. AP is what X, AQ is what X plus Y. So is equal to this, and we know it is 4 squared, so MD equals 4. Now we conclude that, okay, this triangle is an isosceles triangle. So if I draw in this triangle, let me draw with green. If I draw the altitudes, let me correct it. If I draw the altitude in triangle AMC, so I can say that it is also an angle bisector because it is an isosceles triangle. So you can say, okay, let me write, okay, I is here in center because lies on an angle bisector of C. Now let's see, we want to find what? We want to find AM. So if I find T, AM is 2 times AT. We know it is 6, so this angle is what? we can say if we consider these angles, we can consider it is alpha. So here is alpha, it is angle bisector, it is also alpha, so it is equal to 6 times sine alpha, so it's 2 times 6 sine alpha, so it is 12 sine alpha. If we can find sine alpha, then the problem will be solved. Here, if we draw, let me draw with red, this line, it is what it is in radius, so if I find R or CI, then I can find 2. So let's see, can we find R for, here we know BAC, the problem says BAC is 60 degree. So if I draw this angle is 30. So we can say, okay, this angle is 60. So because it is 30, AI over 2, or let's at first do this. AI times sine 60 root 3 over 2 equals 4. So AI equals 8 over root 3. And or we can conclude is half of AI because it is 30 degrees, sine 30 is 1 over 2. So we can say R is half of AI, which equals 4 over root 3. Now here we can say, okay, R equals 4 over root 3, it is 2. So we can find CI to find sine alpha. CI is what? CI squared is R squared 16 over 3 plus this squared is 4. So it is 4 times 3, 12, 12 plus 16, 28 and over 3. So CI equals, you can say, root 28 over 3, which equals 2 root 7 over 3. Now we can find sine alpha easily. Sine alpha is what? Sine alpha is R over CI. So R is what? 4 over, it is root 3. 4 over root 3, or we can write 2 root 7 over root 3. You can cancel this 2 root 3. So it will be 2 over root 7. And if I replace here, it will be 12 times 2 over root 7. Now, if we simplify, if we rationalize, AM equals 24 root 7. You multiply it by root 7 over root 7. It will be 24 root 7 over 7. So the answer equals AM 24 root 7 over 7. Hong Kong Mathematical Olympiad 2021 Preliminary Selection Contest. Problem number 18. On and Ben play a game as follows. On starts by constructing an acute angled triangle A0, B0, C0, which is not equilateral, and in which every interior angle when measured in degrees is an integer. For each triangle A and B and C and constructed by one player, the other player subsequently constructs triangle AN plus 1, BN plus 1, CN plus 1, such that AN plus 1 is the foot of perpendicular from AN to BN, CN, and with BN plus 1 and CN plus 1 defined analogously. The game comes to an end when triangle AKBKCK constructed is not acute, and the player who constructs such a triangle can get K points while the other player gets negative K points. Assume that On is clever so she can construct triangle A0, B0, C0 in a way that maximizes her score in the game. Find the greatest possible value of A angle A0. For solving this problem, at first we should consider the angles of, we call this is altitudes, AD and let me BECF, and we call this is orthocenter, we call DEF orthic triangle. So we should find a relationship of angles of orthic triangle and ABC. So AEDB is cyclic. It is, this part is geometric part of the problem. AEDB is cyclic. Why it is cyclic? Because 90 see this side, 90 this C side, so same angle see the same side, so it is cyclic. Then we can conclude, okay, because this is A, it is 180 minus A, so it is also A. So we can say this angle is A. Similarly, AFDC is cyclic, because 90 the same side, so it is A. So we can understand, okay, angle D is 180 minus A. So we understand if you have angles B, A, B, and C, so the angles of orthic triangle will be 180 minus 2A, 180 minus 2B, and 180 minus 2C. So here on at first, suppose that the angles are A0, B0, C0. Then when Ben creates the next triangle, we have what? 180 minus A0, 180 minus B0, and sorry, 180 minus 2A0 because of the things we proved here, minus 2B0, 180 minus 20. If you want to know angle chasing of this problem, also we have for perpendicular bisectors around 50 important ideas and formulas you should know for solving any problem from qualifying level up to IMO. As I said, feel free to send message to my WhatsApp number in the description and also here. So let's see what can we do in this part. 180 minus 2A0, 180 this. Okay, now we can say, okay, A0, B0, C0. So the angles 180 minus 2A must be, because it says on is clever, so it shouldn't be an obtuse triangle because he will lose. So 180 minus, here we know A0, B0, there are integers, C0 are less than or equal 89, greater than or equal 1. The problem says acute triangle, the first part, and we know each of them is less than 90. Or we can say strictly less than or equal 89. So we can say what? We know it is positive because A is not 90. So we can conclude 2A0 is greater than or equal 180 minus 89, which equals 91. So A0 is greater than or equal 45.5. So we conclude A0 must be at least 46. Similarly, B0 must be at least 46. And C0 also must be at least 46. Now, until this case, if we have this, we know that in the first step, Ben cannot win. Now we should consider second step. If we consider 180 minus 2 times this, so 180 minus 2 times 180 minus 2A0. It will be what? It will be 4A0 minus 360 plus this will be minus 180. 4B0 minus 180. 4C0 minus 180. Because we want to maximize the score, it says what? K points in the kth step, for example, A, K, B, K, C, K. So it says assume that Anna is clever and in a way that maximizes her score. So we want to see, for example, after this step, so it is what? It is A1, B1, C1, A2, B2, C2. We want to see can An reach to, for example, A4, B4, C4, then A6, B6, C6. We want to see K is at most what at first. So if we want to also consider that it is acute triangle, then 4A0 minus 180 should be less than or equal 89. So 4A0 should be less than or equal 96269. So A0 should be less than or equal 6, 7 point some decimal places. It's not important. So A0 is less than or equal this, B0 less than or equal this, C0 less than or equal this. And we see that it is possible. They must be between 46 and 67. Now we consider the next step. When they create A3, then create A3, B3, C3. We know that it will be 180 minus 2 times 4A0 minus 180. It will be what? It will be 2 times this, 3 times this, 450 minus 8a0. So they create 450 minus 8a0 and the other angles. So we want to consider the cases that this is less than or equal 89. So 540 minus 89, which will be 1, 3, 13 minus 8, 5, and 4 less than or equal 8a0. So a0 is greater than equal 5, 51, 6, 56 point something. So a0 should be at least 57. B0 should be at least 57. Similarly, C0 also should be at least 57. Now we consider the next step. A4, B4, C4. We want to see, can we also reach has 4 to reach 6 for on. So it will be 180 minus 2 times this. It will be 540 minus 8a0. It will be what? It will be, it is 3 times 180, so minus 6. So it will be 16a0 minus 2 times 3 minus 6 plus 1 minus 5 times 180. So here the angles are this. 16a0 minus 90, minus 900. So 6a0 minus 900, if it is less than or equal 89, so we can conclude 16a0 less than or equal 989. So a0 is less than or equal 6, 96, 29. It will be 1 point something. So a0 must be less than or equal 61, b0 must be less than or equal 61, c0 must be less than or equal 61. And if we consider, we can prove that they can't reach to A6, B6, C6 because A5, B5, C5. If you consider this, it will be 180 minus twice this, 180 minus 2 times 16a0 minus 900. Then for A6, B6, C6, you can say it is 180 minus twice 180 minus twice 16a0 minus 900. And if we calculate this, let's see what we have. 180 minus 360 plus 4, 64a0, and then minus 4 times this, which will be 3600. If I consider that it is less than or equal 89, let's see what we have. Then 64a0, it will be minus 180. So if we take it 89 plus 180 plus 3600, and it will be what? It will be 9, 8 plus 8, 16, 2, 3, 8, 16, 9. So a0 is less than or equal 6. Let's divide 3869 by 64. 6 times this, 38, and it's 29, and it's 0, and here. So a0 will be less than or equal 60. b0 less than or equal 60, c0 less than or equal 60. But if I consider a5, b5, c5, Control C, then let's see what we have. It will be what? It will be 180 minus 32a0 plus 1800. If it is less than or equal 89, let's see what can we conclude. 32a0 is greater than or equal 1800. 180 minus 89 will be plus 91. So 32a0 will be greater than or equal 1981. So a0 will be greater than or equal 5. And okay, so if I divide this by 32, then I will have 5, and it will be 29, 291. and it will be 9 18 1 9 3 21 28. Okay, so all of them will be greater than 59 point something. So if you want to reach the sixth step, a0 equals b0 equals c0 equals what? Equals 60. And if we the problem says what? The problem says the triangle is not equilateral triangle. Here, in what part? Acute angle, which is not equilateral. So it is contradiction. So it was, yes, it's contradiction or this sign, Hong Kong. Now we can conclude what? We can conclude, okay, we can't reach A6, B6, C6. So we should consider this case. We said here A0 should be less than 61, B0 61, C0 61. If we want to reach the case that it is not acute triangle, but because we've seen that we in after A6, if we want to go we can't reach A6, B6, C6. So here we say, okay, one of them can be greater than that, but we should pay attention to what? We should say A0, B0, C0 that satisfy this condition. We should say A0, B0, C0 that satisfy this condition. Also, it is for A2, B2, A3, and for A1, B1, C1, these conditions. So 46, 46, 46, if you satisfy this also, that will be satisfied. So we should say some angles around this. The problem says what? Then when you have maximum score, try find the greatest possible value of A0. So you can say greatest possible value of A0 is what? So if you minimize B0, C0, let me write the rest of that by black. B0 57, C0 57, and then A0 is, if all of them 60, it will be 100 degrees 60 plus 3 plus 3. So we guess this is our answer. Okay, and when we see that these three angles satisfy all the conditions that we wanted. So the greatest possible value of A0 equals 66 degree. Hong Kong Mathematical Olympiad problem number 19 for positive integer n, let f of n denote the number of ways of expressing n as the sum of the squares of two non-negative integers without considering the order of the two numbers. For example, we have f of 25 equals to y because it is 0 plus 25 or 3 squared 9 plus 16. And explain, find the value of f of 3 plus f of 6 plus f of 9 plus 2 f of 20, 22. One important formula that it is useful, one important idea that is also useful in national level or higher levels, also round one in many countries, is that if p is 4k plus 3 and p is prime, then if p divides a squared plus b squared, then we can prove that p divides a and p divides b. P divides both of them. It is correct for 4k plus 3. You can prove it, use Fermat's little theorem if you had problem how to prove this important lemma. Let me call it lemma. Feel free, as I said, send message to my WhatsApp number in the description and also here. So let's use this. We know, okay, f of 3, f of 6, we want to find this. So if 3, for example, t equals what? Equals a squared plus b squared. Our n is here, for example, 3t. Then 3 divides a squared plus b squared. So by this lemma, we can conclude 3 divides a and 3 divides b. So a is 3a1 and b is 3b1. So we can do what? We can consider that, okay, n equals a squared plus b squared equals 9a1 squared plus 9b1 squared is 9a1 squared plus b1 squared. So because we want to find f of 3 6 to 2022, f of 3 plus f of 6 plus f of 9 to f of 2022, you need to only consider the multiples of 9. it equals f of 9 plus f of 18, f of 27. Because of this, we proved if 3 divides n, then 9 divides n, if you want to write it as sum of two perfect squares. The last one is f of 20, it's 2019, no, 2018. The remainder of this when divided by 9 is 6. So if you consider minus 6, it will be this. Okay, until f of 2016. And we've reached that, for example, if we want to consider 9c equals a squared plus b squared, it's 9a squared plus 9b squared. 9b1 squared is equivalent that c equals, and is this, c equals a1 squared plus b1 squared. So instead of finding 9c, we can find the ways we can write c. So it equals f of 1, it's equivalent. f of 1 plus f of 2 plus f of 3. The ways we can write all these numbers plus f of this over 9. 221, 236, 224. Now we should calculate some of them. So at first we want to calculate this. We say, okay, suppose, for example, we have a squared, b is 0. One of them is 0. So we should calculate this until 224. So a squared is between 1 and 224. So the numbers that we can have is, if we want to say, we can say, okay, a is at least 1, is at most square root of 224, because a is integer, so we can say floor of that. So here we have square root of 224. If we write for other numbers, a squared plus 1 squared is greater than Here, if we calculate, we should at the end subtract the cases that we count them more than once. You say, okay, it is again 1, 2, 2, 4. So a squared is greater than equal 0, less than or equal. Now, also here you could say it is greater than 0, 0, but the result must be at least 1. That's the reason we consider it's 1. So a squared is this, and 2, 2, 3. So you say, okay, square root of 2, 2, 3. But if you consider if a is 0, then we have 0, 1 squared. Also, we calculated this before, only this case. So we should subtract by 1. But let me tell you something. Because we said a from 0 to 2 to 3, we calculated 1 plus, because a is greater than equal 3, root 2 to 3. Because we start from 0, it is this, then we subtract. So it will be square root of floor of square root of 2 to 3. Let's calculate the second one, then you will understand. Here we say, okay, the next one, if we want to consider the cases, plus 2 squared less than 1, 2 to 4. So you say, okay, a is at least 0, less than or equal 2 to 4 minus 2 squared. So here you say, okay, square root of 2 to 4 minus 2 squared. And you shouldn't consider 0 and 1, so you should say minus 1. So if I want to calculate this, it will be square root of 2 to 4 plus square root of 2 to 3 plus, and we consider the next one 2 to 4 minus 2 squared minus 1. The next one will be square root of 2 to 4 minus 3 squared minus this minus 2. And the last one is consider a square root of 2 to 4 minus 2, 5, 6, 8 squared minus 7. Sorry, 8 squared is 64. So here until 10 squared, 11 squared, or we can say, for example, a is the greater one. We say, for example, here we said a is from 2, we've calculated, and because of this we subtracted. So we say a is at least b here without loss of generality. A is at least b, so a squared plus a squared b squared is less than equal to a squared. And we can say, and for example, look, we subtract from b squared here 2 squared. So We can say also it is at least 2b squared. So this part, a squared plus b squared, let me write it here. We say, okay, we say a squared plus b squared, and then we say, okay, that's most 2 to 4. We say 2 to 4 minus b squared. We know a is at least b. Then we say, okay, this minus the number of cases from 1 to b minus 1 minus b minus 1. So if we want to calculate this, we know it is greater than or equal to b squared, so b squared is less than or equal 1, 1, 2, so b is at most 10. So we should calculate until 10 squared minus 9. So if we add up all these numbers, then we reach the answer. So let's see the first one, 224, the next one, 223 minus 1 squared plus 224 minus 4 squared is 220. Then we subtract -1, 2 to 9. Again, 224 minus 9. If we consider 224 minus 9, then we have 14 minus 9, 5, 215. 224 minus 16. If we consider 224 minus 16, then we will have 14 minus 6, 8. And here 1, 0, 208 plus 224 minus 25. 224 minus 25 is 199 plus 224 minus 36. 14 minus 6, which will be 8. And it will be 1, 11 minus 3, 8. So 188 plus 224 minus 49. Let me write here below. 224 minus 49. It will be 14 minus 9, 5. It will be 1, 11 minus 4, 7. 175 plus 224 minus 64. It will be 0. It will be 6, 160 plus 224 minus 81. It will be 3. 12 minus 8, 4, 143. 224 minus 81 minus 100. It will be 124. Okay, so the last case is 224 minus 100. So this part is minus 1 to 9 is 45. Okay, as I said before, try to memorize 1 squared to 30 squared at least. So here, if we calculate them, because we should consider floor of each of them. So it will be 11. It will be 12, no, 11 again. Because 12 squared is 144, it will be 12. 13 squared, it will be 13. It will be 14. It will be 14, 14, 14. Because 15 squared is 225, 14. So if we calculate them, 1, 2, 3, 4, 5, 6. 6 times 14 plus 2 times 13 plus 12 plus 2 times 11 minus 45. Now, if we calculate this, let's see what we have. 84, 26, 22, and then it will be 36. 36 minus 49, 45 is minus 9. Oh, sorry. It's 34. 34 minus 45 is -11. And if you add up these two numbers, it will be 0. It will be 8 plus 2. It will be 110. So the answer equals 110 minus 11, which equals 99. So the answer is 99. Hong Kong Mathematical Olympiad 2021 Preliminary Selection Contest, problem number 20. In triangle ABC, AB equals what? AB equals 15. AC equals 13. And the problem says AD is on. If you read the rest of that, DEFG is a square such that D is on AC and F is on AB. and G is midpoint of BC, AD is 11, DC, so DC is 2 because AC is 13, and also we know AB is 15, so I can consider, for example, AFL, so because AB is 15, it will be 15 minus L. Now, for this problem, we use rotation. We say, okay, if we rotate all things from center D and the angle is pi over 2 counterclockwise. So pi over 2, this rotation. And then we use, so suppose it is R1, R2, you use from center F and use negative pi over 2, 90 degree means clockwise from, let's consider D, this one, G goes to this point, it is what? It is plus pi over 2, it is counterclockwise. The next one, F, from E, you consider to this part. So you consider what? This point, you consider plus again, pi over 2, again, counterclockwise. Now, if we combine them, R1 and R2, if we combine both of them, then we can prove there is a theorem that if you combine them, we have at first, for example, R1, then R2, then there is a center and the angle is pi over 2 plus pi over 2, which is pi. So if you want to find center doesn't change under combining these two. So if you consider G, after the first one, R1, it goes to E, and then next one goes to G. So if we apply at first R1 and then R2, first R1 and second R2, then we will have what? We have, it is a rotation with center G and pi. Now let's erase this part. We want to find a relationship, and then rest of that we will prove it by Stewart's theorem and something like Gauss rules and these things. Now if we consider at first R1 and want to find C goes to what point, let's see. It will be 90 degree to this point, something like this, and then to this point. Then we consider F, this point. We know what? We know if we consider the combination of them, G and pi, C goes to B. So if, for example, this point is K, so we say, okay, it is C under R1, rotation R1 goes to K, and then K under rotation R2 goes to B. Why we say goes to B? Because we know that G, the combination is center G and pi, and because GC equals GB and this angle is 180, so we know C goes to B at the end. Now, the things that we can conclude is, okay, it must be because K goes to B under R2, so we can say it is 90, and also we can say it is 2, it is 15 minus L. Now, the relationship we can say, because it is 90 degrees, so we can say 11 squared plus 2 squared. AD squared plus DC squared equals what? Equals AK squared, because it is 90 degree by Pythagoras Theorem. Also, you can say it equals AF squared plus FK squared, which equals L squared plus 15 minus L squared. Now, by this equation, we can find L. So 11 squared is 121 plus 4, 125. So 125 equals 12 squared minus 30L plus 225. Now, it is 0, 12 squared minus 30L plus 125 minus 125 is 100. Now we can say, okay, if we divide by Z2, it will be minus 50L plus 50, and we can say, okay, L minus 5, L minus 10. So L can be 5 or 10. So one of them is 5, one of them is 10. But the problem says AF is greater than FB, so it must be 10. It must be 5. So Stuart's theorem is this. You should memorize that. It's so much useful. And the proof is that you say, okay, for example, it is d1, d2, and their sum is 180. So cos d1 is negative cos d2. You can use cos rule in these two triangles and then reach Stuart's theorem easily. I said there are around 50 important ideas that you should memorize. One of them is that if you have median, ma squared is b squared over 2 plus c squared over 2 minus a squared over 4, and you can prove it with, for example, Stuart's theorem. So here, if we use that, we'll have what? Z squared equals 13 squared over 2 plus 15 squared over 2 minus 4x squared, 2x. The whole squared is 4x squared over 4, so we have x squared plus z squared is 169 plus 225 all over 2, 9 plus 5, 14, 1, 6 plus 2, 8, 9, 2 plus 1, 3, over 2, it will be 119, 9, 17. So the first equation we found is x squared plus z squared, 197. Now, we want to use, here we know that the triangle, it is DGF because we said DEFG is a square, so it is an isosceles right angle triangle. So if you consider it is y, and DF also we know is y root 2. We want to find area of DEFG, so we should find y. If we use Stuart's theorem in AGC, let's write the things that we can prove. Then we can say what? Let's raise this part. Triangle AGC. We can say if we use Stuart's theorem, it will be 2z squared plus 11x squared equals a times x times y plus a times 13 times y squared. So here we found a relationship between them, but we know x squared plus z squared is 197, so you can say, okay, it is equal 2 times 197 plus 2 times z squared plus x squared plus 9x squared. So we found a relationship that 9x squared equals this number minus this number. So it is 714, 1, 19, 1, 2, 3. Okay, so we can write 9x squared. If we multiply, it will be 26. So times 11, 26, 26. It will be 286 minus 394 plus 13y squared. The first thing you can say, okay, it is negative what? Negative this minus this. So let's write, you can also write it 9x squared plus 394 minus 286 equals 13y squared. So if you subtract 14 minus 6 is 8. 8 here you have 0 and 108. So we can conclude 13 y squared equals 9x squared plus 108. Now we use again another Stuart's theorem. Here we've used only in AGC. In this term, we want to find y squared. In this term, in this step, we want to find Stuart's theorem in AGB. We find another equation in terms of x and y. Then we can find y squared, and y squared is our answer. So again, we use Stuart's theorem in triangle AGB Stuart's theorem. So let's see what we have. 10x squared plus 5z squared equals 10 times 5 times 15 plus 15y squared. So we know x squared plus z squared is what? X squared plus z squared here. We've reached that it is 197. So if we use here, it will be 5 times 197 plus 5x squared equals this number 750 plus 15y squared. So we have two variables, x squared and y squared. We can easily find y squared. And y squared is our answer. If we divide both sides by 5, then we have 197 plus x squared equals what? Equals If we divide by 5, it's 150 plus 3y squared. Now we can say, okay, x squared plus 197 minus this, it will be 47 equals 3y squared. Because we want to find y squared, we replace here x squared equals 3y squared minus 47. We replace it here. Then we have 13. Y squared equals 9. X squared 27. Y squared minus 9 times 47 plus 108. Now let's see. It is what? 9 times 7 is 63. We have 6. 9 times 4 is 38. 36. 36 plus 6 is 42. Now we can say, okay, 27y squared minus 13y squared is what? Is 14y squared. It equals 423 minus 108. 13 minus 8 is 5. It is 1. 1 minus 0, 1. And then it is 4 minus 1, 3. So y squared is what? Is 315 over 14. It is odd even. If we check 7, it is 4 times 7, 35. Yes, so 4 times 7, 35, and 35 times 7, 45 over 2. So the answer equals 45. The area of the EFG equals 45 over 2, because the length of the side is y is square. So y squared is area, y squared equals 45.